Let's try to solve this equation with double square root on the left hand side, right? So square root of a subtract square root of a plus x equals to x, right? So one of the direct way for solving this kind of equation is to actually square both sides, right? But you have to square them twice, square both sides twice, and then you're going to end up with x to the fourth power, right? It's going to be a fourth order equation. And do we have a root formula for solving a fourth order equation? Yes, we have it, but the formula is extremely long, and um, it's very difficult to use that kind of a very long root formula. So can we find a alternative way of solving this kind of equations, right? Yes, we can. We can do that by introducing more variables, right? So here what we're going to do is to represent square root of a plus x equals to y, right? We're introducing one more variable y, um, and that's going to be one of the equations that we're going to try to set up, right? Um, and then if we bring this y into the original equation, we end up with a subtract y equals to x, right? So it looks like we have introduced a new variable, but we have two equations for two variables, right? In principle, we should be able to actually get the solution for both of them, right? So what are we going to do, right? We can actually square both sides of the equation, right? So square both sides of both equations. So a plus x is going to equal to y squared, right? And then a subtract y is going to equal to x squared, right? And now we can actually use equation 1 to subtract equation 2, right? To cancel out the a. So 1 subtract 2, then we're going to end up with what? We're going to end up with x plus y is going to equal to y squared subtract x squared, right? And then we know that y squared subtract x squared equals to what? It's going to equal to y subtract x times y plus x, right? So so at this point, how can we get some can get some hints about the solutions, right? So on both sides of the equation we have y plus x, right? And then y subtract x, right? So what can we do about it, right? So suppose x plus y is not equal to 0, right? If it's not equal to 0, then we can cancel x plus y on both sides. Then we end up with y subtract x equals to 1, right? Then y subtract x equals to 1, and then y equals to x plus 1, right? That's one of the equations that we can actually use for us, right? So if we bring this equation back in 2, right, we end up with a subtract what? Y equals to x plus 1, right? So it's going to be x subtract 1 is going to equal to x squared, right? So at this point we can get x squared equals to x squared is going to equal no x squared plus x subtract a plus 1, right, is going to equal to 0. And at this point we can actually use our root formula, right? So x is going to equal to what? X is going to equal to it's going to be 4a subtract 3. Is that right? Right. In principle, we should have like both a plus and a subtraction, right? Plus or minus, right? But why I'm omitting the minus over here? That's because if you do a minus over here, then it's a minus 1 subtract another positive number. Then you get an x that's a negative number, right? But can x equals to a negative number? No, x cannot equal to a negative number, right? X is supposed to be a positive number, right? Positive number or 0, right? So that's why I'm not including a minus sign over here, right? So that's one solution, right? That's one. Depending upon a, of course, the value of a, right? So if a is some small value, then you could end up with a negative value under the square root. In that case, you don't have real solutions, right? Um, and then this is for what? This is for x plus y not equal to 0, right? So suppose x plus y equals to 0, right? And then for this condition, what do we have? Then y is going to equal to minus x, right? And then we can bring this equation back into equation 1, right? And then we're going to end up with a plus x equals to y squared. Y squared equals to x minus x squared. That's x squared, right? So x squared minus x minus a equals to 0, right? So x is going to equal to x is going to equal to what? X is going to, again, we use the root formula, quadratic formula, right? It's going to be 4a plus 1, right? Yeah, again, depending upon the value of a, we could have no real solutions. It's possible, right? We have to look at what's actually the value of a in order to actually use those methods, right? So now we have two solutions over here, one solution over here, right? So we have three solutions for this strange looking equation.